Hey there, awesome physics students. Let's talk about blood pressure. Specifically, let's talk about how it's measured so we can understand what those numbers mean. So let's start by imagining a situation where your blood pressure is measured and they report it to you as 120 over 80. Well, what does that mean? Well, first of all, the high number, the first number they report is called the systolic number. So that's going to be your 120. And what 120 watts? Well, it's measured in millimeters of mercury. So that's the unit that's used. And then the other number is the diastolic number. And so that's going to be 80 millimeters of mercury. And note that, yes, they report it as 120 over 80, but it's not a fraction, it's not a ratio. They're just reporting it in that way to separate the numbers. All right, so then what is this? First of all, is this a gauge pressure or is this an absolute pressure? Well, we know that pressure differences drive fluid flow. Fluid will flow from high pressure to low pressure. So let us for a second imagine, let's choose this higher number here. Let's imagine that this is an absolute pressure. If this is the case, that means the pressure inside your circulatory system is lower than the outside ambient pressure of 760 millimeters of mercury from the atmosphere. If that's true, then when you get a cut and your blood vessels are opened, then air will flow from high pressure, that's the outside air pressure, into your circulatory system, that's lower pressure. But of course, we know that doesn't happen. When you get a cut, blood comes out, air doesn't rush in. And so that means that this must be a gauge pressure. That is, this is the pressure more than atmospheric pressure, and that the absolute pressure must be 120 plus 760 millimeters of mercury. That's the absolute pressure. Okay, so now I know these are gauge pressures. What do they mean? Well, let's think about how they measure them. What they do is they put a cuff on your arm and they squeeze it, they pump it up and increase the pressure in the cuff. And then they listen to an artery, fluid flow in an artery in your arm. Now, when they pump it up, they cut off the pressure in the cuff is opposing the fluid motion. And so that cuts off the fluid flow in that artery. What then they do is they gradually lower that pressure. And as they lower that pressure, they listen for the first signs of your heartbeat or fluid flowing through that blood vessel. If you plotted the blood pressure versus time, then you would see that your blood pressure maybe starts out, and as your heart beats, it compresses your blood inside your heart and increases that decrease in volume, increases your pressure rapidly, and then it goes up and then it drops off slowly, and then your heart beats again, and so it comes up and down like this. What they originally do is they put the pressure, this is the pressure, they put the pressure way up here so that it's higher than the peak pressure in your system, even when your heart's beating, and so no fluid will flow through. Then they lower this pressure in the cuff, and at some point it's lowered enough so that the peak pressure will just barely be larger than the pressure in the cuff for just a second, and during this portion right here, fluid will briefly rush through, and they can hear that. And so that's the systolic number. That's the highest, that's the upper number here. So that really represents the peak pressure in your system. They continue to lower it, and they'll continue to hear it go from when it's down here below the pressure of the cuff, it won't flow, and then when it busts through, then they'll hear it. They keep listening until they no longer hear it bust through. And at that point, the pressure in the cuff is the same as the lower end of the spectrum, or the base or ambient pressure that's always in your blood vessels. And that is the diastolic blood pressure there. Okay, so systolic measures the peak and diastolic measures the ambient or the baseline pressure in your system. Okay.